Okay, this is lesson 5-2, problem number 12, finding the centroid of a triangle. So what we do, we take x1, x2, x3, add them all together. We need a plus right here.
There we go.
Divide that by 3, that gives us our x coordinate. Do the same thing with the y's. So here we go. 5 plus 9 plus 13 all over 3. 5 plus 9 equals 14 plus 13 over 3. That's 27 over 3. What is that?
9.
X coordinate is 9. Do the same thing for the y's. 7 plus a negative 3 plus 2. So 7 plus negative 3 is the same thing as 7 minus 3, which is 4, plus 2 over 3 to 6 over 3. Y is equal to 2. So our coordinates 9 and 2. Let's see if that's correct. It's correct.
Oh yeah.
Let's go.
So that's how you do it,
Answer
Miles?
right there.
There we go.
Okay.
It's that simple. Hey everyone, I'm Jack, and today we're learning about the basics of indirect proofs. Real exciting. Now, before I get into the problem that we'll be solving, let's just go over the easy steps that it takes to solve an indirect proof. Now, there are 3 basic steps to any indirect proof that you'll be solving on the final. First, identify the proof, and then contradict it. Next, use logical reasoning to show that this assumption leads to a contradiction of the given that you've been given, or any other fact, or some other fact, such as a definition that you know, a postulate, a theorem, and so on. Finally, write a concluding sentence that points out, since the assumption leads to a contradiction, the original proof, the thing you were asked to prove, must be true. Let's see, I wrote it down over here for you guys. The 1, 2, 3 process, it's pretty easy. Now, for this problem, number 27, in section 5.4, all you have to do is apply the steps. First, we identify the proof, and that is angle x is not congruent to angle y. And then we just contradict that, and I did that down there. And that is angle x is in fact congruent to angle y. Next, we simply follow that line of reasoning until something doesn't work, and for this one it comes out pretty easily. So if we note the isosceles triangle theorem, it will say that xz must be equal to yz if this is a triangle, which in fact it is. But hang on, that can't be right, because in the given it has stated that xz is actually greater than yz. So you have your contradiction. And because you have that contradiction, that means that the original proof must be correct. And, well, it's actually that easy. So from there, you just write down a concluding sentence that states that basically, because our assumption, angle x is actually congruent to angle y, is false, the original proof, angle x is not congruent to angle y, must be true. And that's pretty much it. You just solved an indirect proof. Congrats.
Hey everyone, I'm Scott, and today we'll be learning about special segments and points in triangles. And this is basically how to determine if a segment is a perpendicular bisector, angle bisector, median, or an altitude. So let's go on to the perpendicular bisector. Now we all know that to bisect something means to cut it into 2 equal parts, and the bisector is the thing that's doing the cutting. So with the perpendicular bisector, it's basically a perpendicular line that cuts through a midpoint of a segment at 90 degrees. And the point of concurrency is the circumcenter, and the special property of this is that the circumcenter is equidistant to each vertex of the triangle. Next we have an angle bisector. And like the perpendicular bisector, we know that the act of bisecting means to cut something in half or to split into two equal parts. Therefore, an angle bisector cuts an angle in half, meaning the measures of the angles on either side of where the bisector cuts through are going to be equal. And the point of concurrency for this is the incenter, and the special property is that the incenter is equidistant from each side of the triangle. And after this, we have a median. And a median is basically a line segment going from a vertex to the midpoint of the opposite side. And because a triangle has three vertexes, there are going to be three medians. And a fact is that no matter what shape the triangle is, the medians will all intersect at a single point, and that's called the centroid. And the special property of the centroid is that it's always going to be 2/3 of the distance from each vertex to the midpoint of the opposite side. And finally, we have an altitude. And I think an altitude is a bit similar to a perpendicular bisector because we're dealing with two lines that are perpendicular to each other. But instead of a line going from a midpoint straight up, it's going from a vertex straight down, or in any other direction, as long as it's perpendicular to the base opposite of it. The point of concurrency for an altitude is the orthocenter, and the special property is that the lines containing the altitude are concurrent at the orthocenter. So, let's do some practice identifying some of these segments. So in the first one here, we see that we have a segment going from a vertex to a midpoint. And we think vertex to midpoint. Well, we know that's a median, because medians are vertex to midpoint. Now this one, we have a segment that seems to be bisecting this angle. Well, we know bisecting means to cut in half, and it's at an angle, so this must be an angle bisector. Now this one here, we have a segment that is going from the midpoint of the base of the triangle, and it's going at a 90 degrees line straight up, so it's perpendicular to the base. And we know that a perpendicular line from the midpoint of the base of a triangle is a perpendicular bisector. It's bisecting the base of the triangle. And lastly, we have a perpendicular line that's coming from the vertex down to the base, and we know that that's an altitude. All right, and that's special segments in a triangle.